Hi guys, welcome to Elias Academy, and this is your online self-learning portal. Please don't forget to like and subscribe to my channel and press the bell icon to get new video updates. In this video, I will show you how to solve an absolute value equation for the case 1 and 2. As we know our previous videos, we solved that standard absolute value equations. And in this video, we will see some additional problems within that absolute value equation. As you can see here, the case 1, the absolute value equations will be in the form of absolute function ax plus b or minus b equal to cx plus or minus d. And as you can see, there is only one exiting absolute functions on that left, or that could be on the right as well. And the case 2, that is a both side, the absolute value functions exists. All right, now we're going to solve these problems based on the method we adopt. As we know, the absolute sign is indicate the distance from the zero. As you can see, this is a straight line, and say this is a 0, and that could be the distance from on the left, or that can be on the right, which is the distance is the same as on the right, which is we express in this forms, which is absolute x equal to c, and this could be also can be written as and these forms. So we have our two possible ways. The distance from the 0, one is could be on the right, or that could be on the left. All right, take a look at this example. Given that the absolute function 2x minus 5 equal to x minus 1. This absolute value equations, we need to determine the critical points, which is x. So as we know, we have two possible solutions for this absolute function, which is one is a positive side. All right. So when 2x minus 5 is positive, and when the 2x minus negative. So let me consider the first solution. The first possible solution is positive, whereby step 1, so 2x minus 5 equal to x minus 1. So this is a positive solution, which is we simplify these equations, we bring the 2x to the left-hand side. So 2x minus x, and bring that minus 5 to the right-hand side. So we get a minus 1 plus 5. So if you simplify it, we get x equal to 4. So the critical points when the 2x minus 5 is positive is 4. All right, let me consider the negative solution. So negative value of 2x minus 5. So this happens when 2x minus 5 equal to minus x minus 1. So now we distribute the negative into the bracket. So we get minus times x, we get a minus x, and minus times minus 1, we get a plus 1. So this is 2x minus 5. So we simplify it. So we get a 3x, bring that minus x to the left-hand side, and add with this 2x, we get a 3x equal to, and bring that minus 5 to the right-hand side, we will get 1 plus 5, which means we get a 3x, and 1 plus 5 is 6, and we get x equal to 2. All right, so this is the critical point when the absolute function is negative. All right, now the step 2, we're going to determine the critical point is satisfied to this condition. So in order to identify the critical point, satisfy that absolute value equation. So we substitute in and we check that the values on the left is a tally to that on the right. All right, step 2. So we're going to substitute that critical point. So when the x is equal to 4, so we're going to substitute into this absolute value equation. So 2 and sub that 4 into that x is minus 5 is equal to 4 minus 1. And this is 8 minus 5. We get a 3. And 4 minus 1 is 3. So when we comparing the both side, it's tally. So this is a critical point is a solution of when it is positive. Now, similarly, we're going to check the second critical point, which is x equal to 2. And we check again on that absolute value equation. So when the x is equal to 2, so we substitute in the absolute value equations where 2 minus 5 equal to 2 minus 1, and we simplify it. So 2 times 2 is 4, so 4 minus 5 is minus 1. So 2 minus 1 is 1, so 4 minus 5 is minus 1. So as we know, the absolute function, anything in there is always get a positive, so 1 equal to 1, and this is tally. So therefore, we can conclude that the solution of the x equal to 4 and 2 is a solution of this absolute value equation. All right, now take a look. This is a second example. Given that the absolute value function x plus 9 equal to x plus 10. And as we know, we have a two solution of this x plus 9, the modulus function or the absolute value function. So one is a positive solution and another is a negative solution. So take a look on that, the positive solution first. So in the step 1, we performing on the positive solution, which is x plus 9 equal to x plus 10. And we try to attempt to find the critical solution for this. And we get x minus x plus 9 equal to 10. We cancel the x minus x, we get a 0. So this 9 equal to 10. We can conclude that since there is no tally, we can claim that this is no solution. All right. So since there is no solution on the positive side, we take a look on that the negative region, which is x plus 9 equal to minus x plus 10. And we distribute that minus into the bracket. So we get a minus x minus 10. And on the left, we get x plus 9. So we bring that minus x to the left-hand side and add with this x, become a 2x. And bring the 9 to the right-hand side, we get a minus 19. So we get another critical value of x, which is minus 19 over 2. So which means that x is equal to minus 19 over 2. Now, since the first attempts, the positive side, there is no solution, we attempt for the negative possible answer, which is critical points when the x equal to minus 19 over 2. All right, so now we're going to check whether the x equal to 19 over 2 is satisfied the given condition. So in the step 2, we're going to substitute that critical point. So when x is minus 19 over 2, we're going to substitute in the function. So this is x minus 19 over 2 plus 9 equal to minus 19 over 2 plus 10. All right. Now we're going to simplify it. And we simplify it, minus 19 over 2 plus 9. So we get minus 1 over 2, the modulus. And we simplify it on the right, minus 19 over 2 plus 10. So we get 1 over 2. So which means we take this positive. So 1 over 2 equal to 1 over 2, which is this condition is tally. So therefore, we can claim that the x, or the critical value of x, which is minus 19 over 2, is satisfied this condition of the original equations. All right. Take a look this the third example, and this is considered as case 2. And as you can see that the example has the absolute function in the both sides. So which means this condition we called as case 2. All right, in order to solve this equation, so we adopt the same way how we did before the two examples. So we consider the positive side. So as in step 1, so just assume that there's a positive, the 4x minus 3 is when it's positive. So it's a 4x minus 3 equal to x plus 1. And we simplify it, 4x minus x equal to, bring that minus 3 to the right hand side, you get a positive, so 1 plus 3, and 4x minus x, we get a 3x, and 1 plus 3 is 4, so we get a x equal to 4 over 3. So we get a one critical point when the function is positive, which is x equal to 4 over 3. So when we consider the negative regions or negative side, the possible answers could be 4x minus 3, which is equal to minus x plus 1. So we distribute the minus into the bracket, we get a minus x minus 1, and on the left will be 4x minus 3. And we simplify it, bring that minus x to the left hand side. So add with 4x, we got a 5x, and bring that minus 3 to the right hand side, we get minus 1 plus 3, and simplified, we got a 2. So the critical point of x will be 2 over 5. So we also get another critical value when the region is negative. All right. So now we're going to evaluate the both critical point, whether this 2 point is satisfied with the given original function or original equations. So that will be in the step 2. So let's continue. The step 2, we're going to test the two critical point, whether it satisfies that given condition. So when the x is 4 over third, so we substitute the x 4 over 3 into that function. So 4 over third minus 3, and on the right hand side 4 over 3 plus 1. All right. So now we simplify it. So we got that the first solution is 16 over 3 minus 3. And this is, we got 7 over 3. And you simplify it, we got a 7 over 3, which is tally to on the right, which is 7 over 3. So we can say this is critical point is satisfied to the given condition. All right. So we're going to test again for that the second critical point, which is x equal to 2/5. So when x equal to 2/5, so we get a 4, 2/5 minus 3 equal to 2/5 plus 1. And we simplify it. We get an 8/5 minus 3. And once we simplify this, we get 7/5. And on the left, we get minus 7/5. And since we just assume that the modulus function or the absolute function is positive, so this we can claim that the 7/5 is tally from the left and the right. So therefore, we can conclude that the critical point, which is x equal to 4/3, and the critical point x 2/5 is solution of the given original function or the original equation. Thank you guys. I hope you like this video. If you have something to say, please leave your comment down there, and I will see you in the next video.